This sucks because my camera is not recording anymore. I don't even know if you can see the screen. I don't know, so I'm recording from my computer and I'm not very happy. So what we're doing is solving equations or inequalities from two different equations and or inequalities. This is really called a system of equation or a system of inequality. And if this video doesn't work, we'll figure it out later. But right now, here's where we're at. So it's saying, and this is going to be a longer video, guys. I mean, I'm sorry to tell you this is going to be a longer video. So considering the following compound sentence, x plus y is greater than 10, and y must equal 2x plus 1. Circle all of the ordered pairs that are solutions to the inequality. Okay, so here we go. 3 plus 7 is greater than 10. Well, that's not true. 7 plus 3 is greater than 10. That's not true. Negative 1 plus 14 is greater than 10. There we go. 0 plus 1 is greater than 10. Nope. 12 plus 25 is greater than 10. Yep. 5 plus 11, 16, yeah. 0 plus 12, yeah. 1 plus 8, nope. 12 plus 0, yep. Negative 1 plus negative 1, no. Okay. So that's all of the ordered pairs for this. Then underline the ordered pairs that are solutions to this equation. Well, here we go. Negative 1 goes in for x. 2 times negative 1 is negative 2 plus 1. Well, that doesn't give me an answer. 2 times 12 is 24 plus 1 is 25. Aha! So that works for both equations. Love it. 5 times 2 is 10 plus 1 is 11. That works for both. 0 times 2 is 0 plus 1 is, no, that doesn't work. 12 times 2 is 24 plus 1 is 25. 0, no. So there's only 2 that work for both. Okay, list the ordered pairs that are solutions to both 12, 25 and 5, 11. Those are solutions to both. I love when it works. List 3 additional ordered pairs of solutions. Yeah, I'm not going to do that yet. I don't care about that part yet. What I care about, and I'm so worried that you guys can't see this. Maybe it's the glare on my computer. I don't know. I'm more worried about graphing it. Sketch the solutions. Okay. So how can we sketch these solutions? Well, I have one in slope-intercept form. Let's get the other one in slope-intercept form. So when I subtract x, so y is greater than negative x plus 10. Okay. So I'm going to graph the equation first. My y-intercept is positive 1. My slope is 2, which is 1 up 2 over 1. So it's an equation. Where's my stick? Here's my stick. So it's an equation. So I graph just a solid line. Okay. This is for this one. So I'm going to circle this in blue. Let's circle this in black. Because now I'm going to start off at positive 10. And I'm going to go down 1 over 1. This is going to be a dashed line. Why dashed? Because it's just greater than. And then I'm going to graph answers this direction because it's greater than, so it's all of this shading up here. Okay, so describe the solution set. The solution set is everywhere where the lines intersect and above, but not at the intersection. Why not at the intersection? Because where this dashed line is not part of both. But everywhere on this line above it is absolutely a solution. Okay? So this is how we're graphing two different equations. Is it always that easy when we're just graphing? Well, no, nothing's ever easy, guys. It always gets more difficult. Okay, solve the following system of equations graphically and algebraically. So graphically, this is in slope-intercept form. So I'm going to circle this one. And I'm going to say, okay, y equals 2x plus 1. So 1's my y-intercept up 1, 2 over 1. And I graph. Uh-oh. And this is where it's important that you have a good straight edge. Because if you do not have a straight edge, a ruler of some sort, you're going to be off. Now, x minus y equals 7. So I subtract x from both sides. That leaves me negative y equals negative x plus 7. Divide by negative 1. leaves me y equals x minus 7. 1, 2, 3, 4, 5, 6, 7, up 1, over 1. So notice how my line's not going down far enough. Okay, so it appears that they're intersecting somewhere right around here, which is 1, 2, 3, 4, wow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Did I count that right? I hope it's 14. Might be 15. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14. No, 15. Okay. So this is about 1, 2, 3, 4, 5. So I'm getting -5, comma -14. Now, are my graphs perfect? No, because I'm using this funky straight edge. They're not exactly perfect, but I think it's at -5, and actually it's -5, -14 on my graph. I know that's wrong. Graphing works if we've got nice, easy scratch paper and a nice ruler. I'm doing this up on the board. So what's the better version? Is doing it algebraically. So watch what we're going to do. This is called the substitution method. And you actually know substitution. So y equals 2x plus 1. That's what y is. So all of this is going to go in for y. So I rewrite my problem. X minus 2x plus 1 equals 7. Let's solve it. X minus 2x minus 1 equals 7. Negative x minus 1 equals 7. Add 1. Negative x equals 8. Divide by -1. X equals -8. Okay, well, we're looking for an ordered pair because that's how we solve systems of linear equations. So now I have -8. Guess what we do? We substitute it back in. Y equals 2 times -8 plus 1. Y equals -16 plus 1. Y equals -15. So graphing is actually easier, but it's not as accurate. This is absolutely accurate because we get the ordered pair -8, -15, and substitution will always give us the exact answer. Okay, so if you have a choice between graphically and algebraically, I would personally go algebraically because it gives me the exact answer, where graphically gives you a guesstimate. -5, -14, close, but no cigar. So how else can we do this? Let's do another. And we're going to do these a bunch because solving systems of equations is tough. And you should have learned this in 8th grade, but you didn't. So that's why we're doing this now. So solve each first by graphing and then algebraically. Okay. This is actually easier to graph than it is to solve algebraically. So I start at -1. I go up 1, 2, 3, 4. 1, 2, 3, 4 over 1. And again, my straight edge is this stick, which isn't exactly accurate, but it's not horrible. Then I've got +8. 1, 2, 3, 4, 5, 6, 7, 8. And now I'm going down 1 over 1, 2. Ah, this is perfect because it gives me a perfect intersection at a spot. As I said, this one's graphing easier. So over 1, 2, up 1, 2, 3, 4, 5, 6, 7. So I'm getting 2, 7 as my answer because we want where it intersects if it's two equations. Well, how can we check it graphically? Well, here's what y equals, 4x minus 1. So now I've got 4x minus 1 equals -1/2 x plus 8. Solve your equation. Add 1/2 x to both sides. And you can do that in your calculator. 4 plus 1/2, that's going to give me 5, or that's going to give me 4.5, which is 9/2 x minus 1 equals 8. Add 1, gives me 9/2 x equals 9. Multiply by the reciprocal, which your calculator will do. X then equals 2. Well, that matches. So now what do we do? And this is the tough part. We go back up to the one we substituted in. We say y equals 4 times what's my x? The x is 2. Minus 1, y equals 8 minus 1, y equals 7. So I have my x and my y. That's not my answer. My answer has to be the ordered pair of 2, 7. That's the only equation, that's the only answer that works for both equations. That's called solving a system by substitution. That's called solving a system by substitution. This is solving a system by graphing. Let's do one more, like this. And I'm going to check my computer. Is it still recording? We're 10 minutes, 21 seconds in. I hope so, because I recorded one video like 7 times and it really upset me. A little bit trickier. So let's graph it. Well, how are we going to graph it? We need to get them both into slope-intercept form. So I've got 2x plus y equals 4. I subtract 2x from both sides. That leaves me y equals negative 2x plus 4. Let's just graph that one. Up 1, 2, 3, 4. Down 1, 2, over 1. Okay. This guy is 2x plus 3y equals 9. Subtract 2x from both sides. And this is why we spend a lot of time making sure we know how to get into slope-intercept form. Negative 2x plus 9, divide by 3. Gives me y equals negative 2/3 x plus 3. So I'm starting off at 1, 2, 3, down 1, 2, over 1, 2, 3. And it appears to intersect very close to this point right here. And that's at 1, 2. Do I think that's the answer? I don't know. But that's what I appear to have right there. Is it right? I can guarantee that it's not. So how can we check this? And this is where calculators come in handy. I'm going to use this to substitute for y. Where does that go? That goes in for y right here. So now I have 2x plus 3 times negative 2x plus 4 equals 9. And this is where I love algebra and you'll hate it. Use your calculators. Distribute, distribute. 2x minus 6x plus 12 equals 9. That gives me negative 4x plus 12 equals 9. Subtract 12 from both sides. Negative 4x equals negative 3. Divide by negative 4. X equals 3/4. So remember what I said. Graphing can give you a close answer, but not the exact answer. We had 1. Well, x is 3/4. So now what do? We take this and substitute it back in. So now I have y equals negative 2 times 3/4 plus 4. Y equals negative 6/4 plus 4. Your calculator does this for you, but that's 16, so that's negative 10/4. Or y equals negative 5/2. So I have y, I have x, my ordered pair, and it shouldn't be negative. Why do I have negative? Oh, because it's positive. Hold on. This is negative 6/4. When I change the 4 to 16/4, that's positive 10/4. And I knew I did something wrong. That gives me 5/2. So now my ordered pair is 3/4, 5/2, or 75/100 and 2.5. That's pretty close, but remember, it wasn't exact. So, unfortunately, that's just solving equations. And that's already a long time. When we solve inequalities, the only way to solve an inequality is to graph it. The only way to solve a system of inequality is to graph it, which means get it into slope-intercept form. So subtract 2x from both sides, leaves me negative y, less than negative 2x plus 3. Divide by negative 1. Well, it's an inequality. I'm dividing by a negative. Reverse the inequality sign. Gives me 2x minus 3. So I start off at 1, 2, negative 3. Up 1, 2, over 1. I'm making a dashed line. Why are you making a dashed line, Mr. H? Because it's just greater than. I'm not going to shade yet. All I'm going to do is put a big arrow going above it. And I'll explain why in a second. Let's get this one. So here's that. Let's change colors. So now I'm going to subtract 4x from both sides. Why? Because I'm trying to get it into slope-intercept form. Greater than or equal to negative 4x. Divide by 3. y is greater than or equal to negative 4/3 x. So where's my y-intercept? It's at 0. I go down 1, 2, 3, 4 over 1, 2, 3. And I make, this time it's a solid line. Once again, it's greater than or equal to, so I'm going to make a big up arrow. So that means I need to shade above the red and above the black. But if I'm shading above, is there any shading below this black? No. So the answer to the system of linear equations is only this space in between the two, because that's the only place that they're both getting shaded up. When we talk about systems of linear equations or inequalities, we're talking about the overlap of the shading. So if I shade all of this up, this part down here is below the black line. That's not shaded. This part over here is the black line, but it's below the red. So we can't shade both. That's the only area that both are shaded through. Okay? That's important. I'm going to do a lot more examples of this in class because I know this was already a long video, and we're going to do a bunch in class. So trust me, believe in me, I believe in you. Great work. And now I got to figure out how to get this computer to stop. I'm going to keep talking until that does.